And it is pulse width modulation between the Arduino and the servo. Very easy code. It's available from the Arduino site from a demo.
All you have to do is an analog write, and it automatically get the pulse width modulation.
Yeah, you do a write. They have a servo library.
Yeah.
And you do a servo.write, and you don't care. I learned a lot about servos this week. I got a servo demo video I'll play in a minute. This is the basic lineup. This is the actual what's happening now. You see 170, that's my target. That's what I set as the set point. This is going to be the set point. This is the actual set point, by the way, of the trash can transport. 170 gets it straight up and down the driveway. And 350 is the other one, I think. The opposite
So this
direction.
works great if your driveway happens to be in that direction, right?
Yeah, but you can change the set point. It's just a variable. The current
We're not
course,
quite there yet.
this is the actual coming from the compass. And you see it's 170, 170, 98. It's all staying within 170. Okay, so
171. Ooh, it just jumped.
it jumped up to 171, but you can see it's mostly 170 right there.
Yeah.
That's close. That's rigid, man. That's unbelievable. And then if you average that, it's really accurate.
So what's this part?
What? That's compass right there.
So
Yeah, I understand that. What is the part number of that?
It's in the code. It's a HT something something. I'll show you the code in a second. It's right in the code, and it's under Jim's corner. You can get the compass separate, and you have the servo separate, and then you got the guidance is them together. And just go on eBay and look for compass, and you'll find them, and then the number.
How much was it?
It's less than $2.
Okay.
And it's
I think we paid less than that for it.
yeah, I2C. Only Leroy would quibble. Less than $2. Yeah. He can get it cheaper. This is our life here. This is what we do. So yeah. So the course is. You see, it's pretty stable. And then I calculate the error, and I also differentiate between a right error and a left error. And the servo is the number of degrees. So right now the servo is set for 190 degrees. Okay, that's direction. It's going to try to turn you to 190. It's saying go to 190.
But your servo is only 180 degree servo.
Right, but I'm talking about the direction.
Okay.
It wants to turn me to 190 degrees. It's trying to turn this to this. This is the tongue of the wagon.
Yeah.
It's going to try to turn me to 190 degrees. It's saying the error is a right error. I'm to the right of the target, so it's going to try to turn me to the other direction.
Okay.
So,
And then if you go to the other side, 70.
so it's moved quite a bit.
170, 100, okay, here we go, 160. Oh, it's coming from the bottom up.
Your servo.
So
moved a
left
little.
arrow, that's a left arrow. And that, okay, it needs to turn left now. Okay. Let's see, where am I? Okay. And then it needs to turn back to the left. I turned it to the right, it's turned back to the left. I turn it to the left, it turns back to the right. So what I found out with the Bitty Rover and running it up and down, I really the way it was working differently. It didn't have a steering wheel; it just had motor speed. I just needed 2 motor speeds, and all that traveling up and down the driveway I did was with 2 motor speeds, left and right. And it was continuously going left, right, left, right, left, right. This is going up the driveway.
Yeah.
And it didn't have multiple speeds. That was it. It wasn't
Oh,
proportional speed. It was just left or right. So that's the way I'm doing this. There's just, it should be pointed about 170 degrees.
Says 150.
The wagon is pointed, yeah, it's 165 now is where the wagon would actually be pointed. And then it's going to try to go to 170 by either left or right. Now, I could have done that with a solenoid, but solenoids, you don't get good torque out of them. I'd like to have, okay, when I looked up the servos to do a video here, I found that there are much better servos for what I'm doing in this. And the linear actuator servo was what I found to be, that's really what I want. Okay, and I found one with a 2-inch stroke, which would probably be ideal, or it's about $30. And it'll handle about 240 pounds, which is a little more than I need, but the tongue is going to go the direction it's supposed to go. And with not much of a stroke, that much 2-inch stroke. I also got a 4-inch stroke, which I think may be overkill. But I got the 2-inch on order, and I bid on the 4-inch.
And I
So it was only moving when it was off?
Yeah.
It would move when it was on target?
When it's on target, I don't mess with it.
It just runs. When it
Yeah,
goes off target, you're turning one off?
yeah. What happens is, what really happens is you're turning it when you get to the past the 0 mark. It's going to turn it to the other direction. It's going to take a little while to catch because it's like 20 degrees. It's turning it 20 degrees that way, okay? And you're going to be drifting that way. And when you get there, past your 0 point, it's going to turn it to 20 degrees the other way. And that's adjustable. I just started with 20. And then it's going to drift the other way. So it's constantly drifting back and forth, and that's what it does. Actually, there is no 0. 0 is considered left, I think. I didn't leave 0 out. It's there, but it's considered left.
I was saying, did you write code for one of those bitty bots that had compensation if one wheel was spinning faster than other?
yes.
Hey, Frank.
Shift your pulse
And
width.
he talked about putting an encoder on that to try and compensate for some of that.
Yeah. This one, we don't have
Because
to
I had
compensate
an
for.
encoder to try to figure out if one was going faster or slower or whatever.
Yeah.
It worked for the most
What
part.
happens if you lose traction then?
That's
That's why we have oh, yeah, that's another issue.
what I was, because like
Yeah.
the bitty bot that I
You may
had,
have the wheels moving at the right rate, but if they're slipping in the snow or whatever.
right.
There are a couple of options for that. One of them is to use the light. I had a light distance calculator. Or was it light? Yeah, it was light.
You were using light.
That made sure it's in a straight line. Also the encoder, and I probably need to do a ground movement detection or something. Rough ideas on that. Or a destination detection. Uses the encoder.
So in other words, like a surface-to-air missile kind of a thing where you get on a target and zero in on the target.
Now this should keep you on the target.
You know.
Okay. And there are several safety measures, and we'll talk about those. But one of the things, then we need the distance. If you're on target and you go the distance, I use the encoder for the distance.
Yeah.
Okay. And also we need a destination detector to say you should be there by so many counts.
What about your compass?
Compass is not going to give you a destination. It's going to go
That's-
straight
that's-
line.
But you have a heading.
Yeah. And it's going to go with a straight heading, but when's it going to get there?
GPS.
Yeah, well, that's not gonna work.
Yeah. It's too expensive, we found, for the GPSs for
It's not accurate.
that accuracy.
Oh,
And, okay, and what we could do is a detect when you're there with some sensor, a whatever,
white line or a
scanner, whatever,
A detonator.
a detonator, yeah,
Shiny
whatever.
laser on it.
You can detect a line, but
Yeah, detect something that's buried there and it should be there by that.
it doesn't have to be buried, just paint it.
what are the little tags that you scan? RDF,
RFID.
RFID?
If you're getting that accurate, that close to being
Yeah.
that accurate, you should be able to scan one of those tags.
Yep.
Um,
And if you get there and you're not there in so many counts, that's it, you're done. Cut it off. But we should be able to read an RFID tag buried, or on the surface anyway,
I
at
don't
the
know
end.
about buried, but
Yeah.
surface, no.
And let's see, other ways, another one I thought of is like the mouse. The mice these days are detecting motion when you slide it on the surface. You should be able to use that technology to detect ground motion.
Well, what do? They have built-in accelerometers or something or other that,
No, it has to do with the reflective nature. You have to have a textured surface. So they're looking at the surface and the movement of the surface.
okay, so, well, that's the way optical mice will work for, those optical mice are invented, so.
That's what I think would be a good thing for the safety circuit to see if it's slipping.
Yeah. Well, I mean, in the real world, anytime you've got something with wheels, you know, unless even dragsters have slippage, okay?
Yeah.
You gotta have something that says,
You got slippage or not.
or not, you know.
That's what my code was trying to compensate for, because on this table, that one wheel just did not work real well. So if the count was way off, I would speed up the other side so that it would keep going straight. Or speed up, I forget which one. I sped up one of them so that it would stop
It's
slipping.
going really slow, so
Yeah.
are you gonna anticipate that much slippage since you just,
It could if you're on snow or ice. It
Yeah,
could
I
slip.
mean, this thing is to push a trash can, right?
Trash cans inside of it, but yeah.
Yeah.
But probably slippage is not that big a deal. In this case, if you do have slippage, you're not going to make it to your destination in time, and it's going to trip out. Oh, if you do have slippage. And then if your direction gets too far off, I'm going to whack you in case you're slipping sideways.
Yeah.
And
Another thing I ran into using the compass is if you have a car nearby, that's going to throw you off. So I'm actually going to use two compasses. It'll actually go find the car, okay. We'll go find the car. It'll go up
So
under the car.
the magnetic engine block is enough to,
these these compasses, they're very, very sensitive.
So what I'll do is run two compasses, and if they disagree by more than or two,
so what physical principle is actually working on? Are they embedded Hall effect devices, or are they measuring the field of the planet, or what are they doing?
they have to be measuring the field of the planet.
I know the answer.
Okay.
It's magic.
good answer.
I'm a physicist, I don't believe in magic.
They if I remember right, when I was messing with them, it actually is looking at the field of the planet, because you actually
Well,
have
you can do
to,
that with a little Hall effect device, among other things, there's a variety of ways to do it.
you go in and you compensate with where you actually are located within a certain geographical parameter, which I don't know if you probably did it because yours is way too accurate.
All I need is repeatable.
Mine got off if I changed that number though. So
The degrees are, well, you know, they're physically off.
Yeah.
In the real world, but
Well, but you're not up around Hudson's Bay or someplace like that either, where basically the North Pole points south. I mean, you are down here, you're off by a few degrees, and
it was a very small number, but changing that small number changed the degrees quite a bit.
yeah, and it's like him using the GPS. We didn't care really about the accuracy as long as it's repeatable.
And it wasn't as repeatable as it should have been.
repeatability. So anyhow,
It
so
wasn't quite as.
I got the code down for the guidance. The code's pretty, it's in my corner. all the code. I got the compass, I got the servo, and I got the compass and the servo doing guidance together.
You have the drive working with the chain and all that?
Yeah.
You
I've
guys
got
see
the drive working. No, the drive's right here. 43 amp drive, and that's to be added. But really, these are independent. The steering now is different from the drive. In the Bitty Rover, I was actually doing messing with the drive and two motors. This one, I just, as long as I get speed out of it, I don't care, because I'm going to be doing direction with this. Okay, let's look at a video about the servos. This is good stuff. I can find it. And we'll see if we can play a video through this thing and see if the audio comes through. This will be, I'm retraining on this, wing, projects, and video one, how servos work. They had some excellent videos on YouTube. Yeah, I need to find out how to cut the audio down.
It's coming off the TV.
Yeah, volume up in there, if you will. Hope you guys get to see it. Yeah, start. Don't try to recognize the song. I think it's in another language.
Or read the text.
Yeah, there is text in multiple languages. So they have an excellent video for 4 screws, bottom plate, the circuit board.
Stuff.
Yeah, got a resistor across the motor.
$14,000 different gears.
That's serious torque.
294 to 1 ratio.
The plastic.
Yeah, that one's plastic. That one's metal. French 78, yeah. That's the potentiometer. Yeah. This is just excellent 3D work there, I think.
So this is the sales pitch.
I don't know what this is.
I got a song,
It's on,
Servo.
all I know is a tree on YouTube.
I spent a lot of money producing, a lot of effort.
Yeah, somebody did a lot of effort. There's
So
the
what
one
they
that did
did
it.
Only graduate students, which means they didn't spend any money at home.
free labor.
2005. Okay, let's see.
Oh.
Hey, your router's slow.
Yeah,
Or the library.
I think it's got to be the library.
As the library got about the same for both of them.
We found the library is about 5 meg down and 20 meg up.
Yeah, it was an
Say it
insane.
again?
Yeah, it was
5 meg
insanely
down.
fast going up.
Yeah, 5 meg down, 20 meg up.
That's bizarre.
I think that's my problem. Maybe, you think that might just be from just usage? Because I'm pretty sure a lot more people are going
We'll
to
run it.
that.
We'll run it here in a minute, but it's been pretty consistent. It's a little better actually out there, I think.
I think they're having some kind of problems because I've been disconnected twice now since I've been here.
Well, you have those issues, but yeah, maybe me too. Usually we don't. I guess we reconnect easier. We use
You're sharing it
Yeah,
at 5 megabit.
1,000 people in here.
speedtest.net.
That's what I used.
I use PC Pit Stop.
An error occurred. Learn more.
Try to play it again, see if it doesn't correct itself.
Well, if it's cached, it
May have some of it.
how do I connect to the little box over here anyway?
There's no password.
There's no password.
No, I'm not talking about the network. I'm talking about Comcast or whatever it is. How do you connect to
Your
that?
router, what's the name?
Oh, the
Chrome.
Chrome.
How do you connect to Chromecast?
You need Google Chrome, and
Yeah.
you need the Chromecast extension.
Okay, that I can do.
And once you get all that, as long as you're connected to this router, you click on the extension and it should bring up that it sees that Chromecast.
Okay, so I've got Google Chrome going here. How do I get the Chromecast extension?
It's in the Chrome store, whatever that is.
So
I'm
if I
having
go to
issues,
more
too.
tools,
I may have to reconnect.
is it in more tools or what? Extensions.
It's there should be applications.
the Chrome Web Store, which I guess you just got to Google it. Chrome Web Store. It should be in there.
Application is not responding.
Sounds like a personal problem.
Okay, Chrome Web Store. What is it, under extensions?
I think it's under extensions.
It's taking everybody down with it. Oh, okay. Well, that went. Let me check my network connection. Connected, open.
Nothing's happening here now.
Yes. Now, Jim's done broke the internet.
Okay, I'm reconnecting.
That's a bummer.
Connected, open.
Chromecast has stopped.
Okay, I need to reconnect to Chromecast because I blew up the connection.
I got a little spinning doozy-woozy here, but I got no action.
Restore.
Oh, yeah.
Extension. Wow, all of a sudden I'm doing extension.
The Chrome Web Store, there should be like a little search block.
Actually, I can play this directly to the, that's true, I should Chromecast directly to that. That eliminates some of that foolishness. Okay, there it is. That's from Chrome to that guy directly.
I'm still looking, still looking.
So you said,
Nice logo.
extension?
Yeah?
Yeah.
Well, you're in the Play Store.
Okay,
So what do I do, look for Chromecast?
Look for Chromecast or Google Cast.
968 or whatever it is.
Oh, there it goes.
Now this guy's English is not that great.
Servo mechanisms, also called servo systems or just servos, have countless applications in the aircraft and automation systems. To help you understand the big picture, I will start by giving a very brief overview of a typical DC servo system. A detailed description of the main sections of a servo system will be given later in this tutorial. The primary purpose of a position servo system is to control the position of the load it is driving. The load in this illustration is in the upper right corner of the video and could be almost anything: an aircraft control system, a weapon system or a cooling door, etc. I have added 8 test points labeled TP1 through TP8 to help make the circuit analysis easier. In the circuit, the load is moved by a DC motor. In aircraft systems, the load could be moved by AC motors, hydraulic actuators, or pneumatic actuators. This particular motor is powered by a variable negative or positive voltage developed across the input potentiometer. The signal developed across the input potentiometer is sometimes called a demand signal or a command signal. A negative 12-volt source is connected to the left side of the potentiometer, and a positive 12-volt source is connected to the right side of the potentiometer. Right now, the wiper is halfway between the positive and negative voltage sources, so the voltage developed across the potentiometer is 0 volts. This 0-volt signal is applied to TP2. Now watch the wiper of the input potentiometer. I'm going to rotate the wiper counterclockwise 45 degrees. Because the wiper is halfway between the 0-volt position and the negative 12-volt supply, a negative 6-volt demand signal will be developed across the input potentiometer and applied to TP2, which is the input of the error detector. The error detector consists of 2 1,000 ohm resistors. For reasons that I will explain later, the output of the error detector, which is TP3, will be about 1/2 of the input. In this case, we applied negative 6 volts to the input of the error detector, so the output will be negative 3 volts. This negative 3 volt output is called the error signal. The error signal is applied to the input of the amplifier. Again, the negative 3 volt error signal is applied to the input of the amplifier. This amplifier has a gain of about 25, so the output in this case would theoretically be negative 75 volts. I arrived at this value by multiplying the gain of the amplifier, in this case 25, by the input voltage of the error signal, in this case negative 3 volts. In reality, this amplifier is limited to an output range of negative 12 to positive 12 volts. So in this case, the negative 3 volt input signal will result in a negative 12 volt output signal. The negative 12 volts from the amplifier is applied across the motor. As you will see in a moment, this will cause the motor to turn clockwise. Because this motor is connected to a gear train to the load and feedback potentiometer, they will also turn. Now watch the load and the feedback potentiometer. Both will rotate clockwise 45 degrees and stop. Look at the feedback potentiometer. A positive 12 volt source is connected to the left side of the potentiometer, and a negative 12 volt source is connected to the right side of the potentiometer. The feedback potentiometer is wired exactly the opposite of the input potentiometer. Because the wiper of the feedback potentiometer is halfway between the 0 volt position and the positive 12 volt supply, positive 6 volts will be developed at the wiper of the feedback potentiometer and applied to TP7. The positive 6 volts will also be present at TP8, which is the input of the error detector. Look at the error detector. Negative 6 volts from the input potentiometer is present at TP2, and positive 6 volts from the feedback potentiometer is present at TP8. Because equal and opposite voltages are applied across two resistors of equal value, the voltage at TP3, or the summing point, will be 0 volts. With 0 volts applied to the amplifier's input, the output will also be 0 volts and the motor will stop turning. It is important to understand that the motor stopped turning only when the feedback potentiometer's voltage was equal and opposite the input potentiometers. In this case, the negative 6 volt input at TP2 was matched by a positive 6 volt feedback signal at TP8. If you don't understand this concept, don't worry. Later in this tutorial, I will cover potentiometers and voltage dividers. Before we proceed to the next section, let's recenter the load. Watch the wiper of the input potentiometer. I'm going to rotate the wiper counterclockwise to the original 0 degree position. Because the wiper is halfway between the negative 12 volt supply and the positive 12 volt supply, 0 volts will be applied to TP2. With 0 volts applied to TP2 and positive 6 volts applied to TP8, the error signal at TP3 will be 3 volts. The positive 3 volt error signal at TP3 will be amplified and become positive 12 volts at TP5 and TP6. Now watch the motor. The positive 12 volts will cause the motor to turn counterclockwise and recenter the load and the feedback potentiometer. Because the feedback potentiometer's wiper is centered, the voltage signal at TP7 and TP8 is 0 volts. With 0 volts applied to TP2 and 0 volts applied to TP8, the output of the error detector at TP3 will be 0 volts. Likewise, the output of the amplifier will be 0, which will be applied at TP5 and TP6. The servo motor will not move from this position until a position difference exists between the input and feedback signal.
Okay, so that's how basically how the op-amp circuit in it works. And you notice the input potentiometer is a voltage input basically. And the input to this servo, although we said Art is right, it's pulse width modulation, they convert it to an analog voltage by using a low pass filter. They're just taking the
Smooth it out.
They smoothed it out basically. For a small pulse, it doesn't charge the capacitor up as much. For a wider pulse, it charges the capacitor up more, and they use a two-phase filter to get most of the ripple out. And that's the third video, and I'll put the list on the meeting announcement page. Goes into that and how all this works in more
Well,
detail.
you just use a Pi network like you would on an old-fashioned power supply, where you have the output of the transformer or output of the bridge rectifier fed into a capacitive, inductive, low-pass filter.
Yeah. Okay. Some of these guys may not be.
Did you find the extension?
No, I've got the extension installed, but I need to know where to go now.
Okay. I'm going to help Art for a second.
Okay.
Just because.
Okay, so the extension's involved is installed on my Chrome, so where do I point it to?
This little magic thing that just appeared.
Here?
You click, yeah, no, the one that looks like a PVC.
Okay, Jeremy, you want to
Click on
attach to
that.
that? Here, any?
Sure. Hang on a second.
That's the Chromecast device,
Mhm.
and it's already casting to YouTube. If you just want to cast your screen, just click cast, and
There you are. There I am.
and there's other options. You can cast your entire desktop, or you can cast just a single tab like you're doing now.
So, but how do I get what he had projected?
Oh, it doesn't work like that.
Oh, I can't.
You're casting your screen.
I see. Okay, I got it.
It's like a presentation kind of thing.
So how do I shut this off? So I'm
Click on that again, and then it should give you the option to click stop.
stop. Dang. Oh, wow.
So you actually learned something new, but it's not exactly what you wanted to learn.
The Chromecast Talk, you can get them for about $25 regularly.
Yeah,
Okay.
that's the little wall wart you got over there?
That's the black one that's plugged into the HDMI port.
Okay.
That you point that
So
at
that's
your
just-
router. That's just pointed at the router.
So that's just, the green line is just power, right?
Yeah.
Okay.
Yeah.
Okay.
Yeah, you got to power it somehow.
Normally you find them plugged into your TV with the HDMI port. They
Yeah.
have a little hockey puck on them.
So is the output of that HDMI or is
Yeah.
that?
Yep.
Okay.
Yeah, that's what you're.
You set it up pointed at your router,
Mhm.
and then you can get to it.
Yeah,
on your
well, I
Wi-Fi.
understand. That part I understood. I just didn't know what the whiz-banging was on the Chromecast
He-
software.
He thought that he should be able to see what you were doing on his computer. It's a presentation thing, so.
Yeah, right.
Okay, sorry. It's your turn.
Hey, so, okay, web APIs. So this is actually not as complicated as you think. So, all right, you want to make IoT stuff. I think this is essential. Basically, I guess to put it in a really, what's the explain it like I'm 5 or 15 or something. Making websites for machines, not people. So, okay, let's say we have. I just launched into this. It's easier. Let's say we have. What's an example? Someone give me one. We have a garage door opener. Anyone got a less boring one? Okay.
What's he saying?
Actually, you know what? Let's
As good as it gets.
Yeah, what are you talking about? Less boring?
Okay,
That's
you know what? Let's
exciting.
make it more interesting. Let's say this is a garage IoT garage application. It does two things. It opens and closes your garage door. Actually, let's call it a storage unit. Storage unit slash garage, and it has temperature. It has temperature. Okay, so here's our little garage slash storage unit thing. Okay. Let's say we went through this and we've got this nice little our little web app, and it's got little buttons on it So like we got a piece of data. We got the temperature inside the garage, so our stuff doesn't roast. And we got buttons to open and close the garage door. Great. I think we know how to get to that point. So okay, great. Now we can get to a web page somewhere and open and close our garage and get temperature of the stuff inside. Now let's say maybe we want to build on that. Okay, maybe we want to make a mobile application that talks to that site or talks to that server and does that stuff too. Maybe we want to have a hub or something. Like let's say we got like another server hosted somewhere. Let's say we're on AWS or something, or Heroku, it doesn't matter. Yeah. We have other application here, and it wants to talk to this guy. Well, code does not like navigating web pages. So what do? Well, we make an API, which sounds scary because yeah, oh no, we're making an API. I use APIs. I don't make them. In this case, it's easy. Basically what we're doing is we're going to make some web stuff which is easy for machines to talk to. And what does that involve? Well, first of all, we don't need HTML anymore because we're serving a machine, not a person. So we don't need that. We don't need CSS. We don't need HTML. What we're passing is usually strings. That's about as simple as it gets. So we're going to make it. What we would do is maybe make a web API and it would talk to that instead. So I don't know. Understand so far?
So this API is going to use the same string that you would use if you press the button.
Pretty much. Well, actually, I guess basically it would be serving a string in place of a web page. When you request a web page, you do a GET request and you request the HTML with all your pretty things and whatever. The application you're going to write up here doesn't really care about that. It's going to do an HTTP request and it's expecting the data you want. It'll probably look something like that, pretty much. So, what do you need to do that? Well, you've already got a web page set up. I think everyone already knows how to do that. So, basically, the only thing you really need to do, I guess, technically, is to instead of serving the HTML, you serve a string or some sort of data that you want to do. So, let's say we have an endpoint and we got it called whatever the heck our site is /API in order to just differentiate from the rest of our site, and we call it something that we're going to recognize at the end. Garage door opener.
That's clever.
Garage.php.
Well, you wouldn't. I don't even know if you'd really need the PHP. Garage door, and basically. What you do is you have the application send an HTTP request to whatever your site is /API/garage door, and then when you send a request there, open the garage door or close the garage door. Or I guess that in its basic form, then you basically have an API. Let's say if you want to send get temperature, you could have a /API/garage temp. You send a GET request there, and it'll get you a string. You know what? Let's do JSON because XML can go kiss my ass up. That says maybe temp, and they're going to be strings.
It's some number.
Some number. Let's say it's cool. Let's say 20. It won't come back with HTML or anything. It's just going to come up with a string. The request body that you get back using the GET is only going to contain a string that has, well, that's a JSON list if you don't know. Then that's an object with an attribute temp and 30, and then you can just parse that and say, hey, I got a temperature of 30. So yeah, so we can do things and we can get stuff back out of it. Again, you'd be using the same web stack that you use for your site pretty much. The only thing is you're serving that. So actually, it's even easier than making web pages. So if you got
How are
that,
you going to display it?
that's this guy's job. That's the application's job. You're writing a new application that's using this. Now, I guess as an example, like what if you have like multiple garages? And you want a central hub to manage it all, and it's on a server hosted somewhere else. You can have APIs for all your all your individual garages, and your hub can request and do data to all your garages. So basically, it's the same thing that you were doing with the web page, but it's machine friendly. Yay! Well, okay, so we got these two things. We can have an API. Now, I guess that kind of covers the technical portion of this. Now, the hard part with APIs generally isn't the technical portion of it, because that's pretty straightforward. If you can make a web app, you can make an API. But the trickier part is making one that doesn't suck. So there's certain things that machines and programmers were gonna like that people who are visiting your web page. That's different from people visiting your web page. For one thing, we don't really have to be all that conservative about how many URL endpoints we've got, because we don't care. You can have as many as you want. So that's a good way to divide up things. And the other thing is that, well, if you have a user that's using an application and that application is trying to go to another application or to do something, you want that connection to be very reliable. So there are some design concerns that you want to be aware of. One is that we've got a problem with this guy because let's say if we this guy doesn't handle data, he just requests to him and he does something, and he returns a status code 200 that hey, I'm okay. Same thing's okay. Good. So what happens if we do it once, the request seems to fail, and we do it again? Well, your garage door just opened and then closed again. So okay, maybe that's not the best idea. So I guess one design concern that you want to look at as far as APIs go is something is a fancy word called idempotency. And that is, you want an operation that results, I guess the short way of saying it is you want an operation that results in the same state if you repeat it as it did the first time. So if you have a URL endpoint that if you do a request to it opens and closes your garage door, then that's not idempotent. That's not idempotent because if you do it once, it results in your garage door opening. If you do it twice, it results in it closing. What if it fails? What if we send it and we don't get a request back for whatever reason?
Feedback.
Yep. Or we need to be able to safely repeat it. So let's do this. We have API / garage open or / API garage close. That's one way to do it, because now both of these guys are idempotent. Because if you do open, and if for some reason it doesn't look like it worked, you can send open again, and you know that if you do it until you get a positive response, that the garage door will be open. And if you do it closed, it's going to be closed. That's not the only way you can do that. What if we did a REST pattern? You can look up what that is, but that's common if you have APIs that serve data. What if you could also do something like use HTTP verbs? Like what if we treated the garage door opening as a session or something? I mean, this is not technical. This is just we're purely talking vocabulary at this point. Garage opening. What if we post an open? So if we send a post with, then it's like we're posting an opening. And if we do, we can also do a delete. We'll delete the opening, and that's what closes the garage door. Both of those could go to the same endpoint, and that would be idempotent because we're using 2 different verbs in order to do it. So that's a way to do it too. But basically, you want to make it so that you want to make it so that it's easy when you're coding the other side of this. How do I get my desired state out of the machine I'm doing, out of the machine I'm trying to operate? Follow so far? So like, let's keep going. One moment. Yeah, my laptop password is that long. Okay, so now you got an idea of why you'd want to do this. So let's get into a bit more of an example, a little more detail. Let's have our garage door thing, or our garage thing. Let's say, because now if you have an API, then you can have lots of applications talking to your garage door thing. Let's say if you have your hub. Hello? Let's say you have maybe you have a mobile application. Basically, nice thing about this that since you're using HTTP, you can operate it from any device that can send an HTTP request. So maybe your hub server, maybe your mobile, or maybe you have like a little desktop application or something. Because join the party too. So you can kind of see why this becomes useful, if like, and why this becomes really useful. So if you have like a web application for something, you might as well build an API for it, and so that then you can build whatever the heck you want and talk to whatever that web app's supposed to operate. Make sense? Now, as far as text that goes, like I said, basically you're receiving and sending HTTP requests. You can do that in any number of languages. PHP is pretty easy. Python, Ruby, .NET. I've used all of those. It's pretty straightforward. And there's and I guess that as far as formats go, you're gonna have a couple main formats to do data in. For example, you could use XML. No. Okay, you could. I'm not one to judge. I usually don't. It's a lot of trouble. It's more brackets. Or you can do like or you can just do JSON, which is just a long string. Hello. We got our. Let's say we got our one. Let's do temp equals 30, and we have open. Hey, we have an object. You just send that as a string, and that's pretty easily parsable. Just whatever is going to be easy to parse the other side. And XML or JSON are easy to parse on a lot of platforms, so that's usually what you want to send. I guess the other concern, which isn't as much a concern if you're working on your own, but the other concern is versioning, since you're basically having, well, you are building an API, an application needs to talk to it, and if someone builds an application to talk to your API and you suddenly change the API, that breaks things. So one of the good things to have is a versioning scheme. So maybe you don't want to have /API. Maybe you want to have /API v1. And then if you make a bunch of changes that are not backwards compatible, you do a v2 and you host both of them until all the other ones get carried over. But you get the idea. So that's actually the harder part of this, really. But yeah, there you have your building block for whatever crazy IoT systems you want to build.
Seems though, okay. I'm thinking about synchronization. I'm thinking about the actual application having to deal with stuff that you can do wrong, since you have this API and you have all of these things out there that can be communicating with you.
Oh, you want authentication? Yeah. Okay. Yeah. That is. I was going to figure out for simplicity. Yeah. It would pretty much be very similar to what you do for a regular application, but you know what? Not entirely the same. So there's a few ways to do that. One is to use basic HTTP auth. You know how you can have a HTTP request header that has a username and password in it? Pass that in. You can do that. You can have a token. Actually, has anyone used Twitter's API or Google's thing? You know when you log in and you get that long ass token? That's basically what that is.
Yep.
So like, it's a machine. You don't need a username and a password, and the machine doesn't care that I have a token that's yay long. So basically, typically, if you have like a public API or something that needs auth, you're gonna have like a token generator, and it has this long string that you then set with your HTTP request that it recognizes. That's basically your username, your password, except it's really, really long and very hard to guess because you don't have a human on the other end who needs to deal with it.
And they rotate. Sometimes they rotate.
Yeah, and you can rotate it if you think the token's been compromised or something. So that's another way to do it. If you're handling something really, really sensitive, then there is a thing called HMAC authentication, which is much more involved and involves like hashing things on the client side and then into something that is very difficult to replicate and sending across, but that's a totally different topic. But yeah, you can do. But yeah, if you have something that's out there on the web and you want to,
like that one. You've got, see where it says key up there? That would be that token key. It's some weird long string.
Yeah, so you can send keys in either as query string parameters, and that's actually okay because if you're doing HTTPS, the query string is actually encrypted.
Yeah.
Query string parameter meaning anything after the question mark, or you can do it in the header, which I prefer to do it that way because. Well, I mean, headers aren't that hard to read. You know, content type authentication. You probably know how to read those on the other end. So, that's how you do that. And there's multiple ways to do it. Pick a standard and stick with it, just to at least make it easier on yourself, so you don't have to guess. I guess as far as that, let's see. How much time we got? I don't have a demo with me right now because I was really busy. I was more busy than I thought I was going to be this week. But how much time do we got? We're about 6:18.
6:18.
All right. You want to see me do something like? I guess you get the idea. You want to see me do something silly and build a demo right now?
Yeah, go for it.
Go for it. Speed build?
Do something silly.
Let's do it live. I have no idea how this is going to turn out. To be honest. Okay.
So this is your opportunity to
Either impress us or
embarrass yourself.
Yeah, because usually these need prep. Okay, so now actually I will say talk's more important than demo because demo is only with one tech stack. I mean, you probably don't use.
you can connect to the Chromecast.
Yeah, okay.
This is what happened to the kids at the competition. We had a competition. Everybody's on their team.
Or actually, wait.
Then they swapped
Let's get a work. Let's go find a working example real quick first. Let's find a working example first.
Well, if you want,
I'm gonna cast in a second.
if you want like a working example for Arduino, that Arduino, the API that I was just using or just showed.
How do I? No. Let's do. I don't know how to do. Can you do a whole screen?
They used you used to be able to.
I think I've got the screen now. Let me get off of it.
You can do the whole screen because that's what I usually do.
Where when you click on the Chromecast thing and it says cast to,
Oh, cast desktop. Sweet. Awesome. Cast my desktop, not my.
You can take
my-
over an existing one always. You don't have to release it, supposedly.
Oh, so I don't have to do anything active to release it?
no,
Okay.
Okay. Entire screen. Let's cast the entire screen.
there you go. That's
okay.
it.
Okay, so I found a good one. So this is this okay. I just went ahead to Google an example. Placeholder, fake online REST API for testing and prototyping.
Oh.
Okay.
A fake one. Woohoo.
Yay, it's fake. It means we don't have to worry about anyone's data getting on screen. So, all right, so this one's got a few different calls. Post, comments, albums. Okay, let's get to it. So this is REST client. It's an API client for Firefox. It's just all it does is it's just a quick UI for putting together an HTTP request and send it off on its way. We'll do this. Let's send a GET request to this thing. And hey, we got, what are we even? Posts. Yay. Okay, so apparently we've got, you see how we have this, it's just JSON. We have a list of, here's our brackets for our list, here's our curly brackets for our objects, and then each object has a user ID and ID title of nonsense words, or I don't even know what language that's in. I think that's Latin. A title and a body, and basically we have a bunch of posts with that much data, and you'd parse, the application would parse that on, you'd parse that on the client side. And there's libraries to parse JSON, or you can always do it manually. There's not much syntax to it. It's brackets, commas. Okay, so that's one that works. And then we could always do a post and then put in, I'm not going to do it now, but we can always put in like a new post with user ID, something, or whatever, and then send JSON back in a post body, and you can make a new post, if that makes any sense. Okay, so that's a working one. Let's build. All right, here's my template app. Let's add an API to it. We're not going to have auth because I don't think I have time to do auth. And this is going to be weird because now I'm just start me a new app. Yay. Okay, we got one. Yay, test API. Okay, awesome. So, all right, we need a URLs. Copy. Paste. Yes. We're gonna make a call called let's do something, because we're very descriptive, and we're only gonna make only gonna make one right now.
No, do something else.
We could do something else. Oh, sorry. Do something. Wrong place. I'm fucking up because I'm going too fast. We'll call it do something. This is a URL router, by the way. View method. And we gotta add it to Okay. Test API and our URLs. I need a new one called. It's going to be called API slash. We'll call it test API slash. I can't spell include. Yes. Uh-oh. Okay, that's not too important. Okay, so let's serve something. We need a request. One moment. I want to do all those imports again. Yeah, same thing. Request. If request method equals what do we want? We want a post. Return. We want an HTTP request. We want an HTTP response. Thank you. Yay for existing code. Actually, wait. Boink. Paste. Response data. What's our response data going to be?
This is something.
I did the thing,
I did
sir.
I did something.
I did something. Oh crap! Import. Import JSON. Okay. Run server. Okay. Here we go. Let's hope I did absolutely no testing at all. Let's find out if this runs. I'm gonna make source code because that's what we do at presentations. Well, first I'm gonna check if the test site works.
Name error.
Ah!
Not quite.
Not quite. Name views is not defined. What the heck? Oh, I know what I did. I was typing too fast and I screwed something up. This is. Oh, that's what I did wrong. I didn't import anything. Go figure. Okay. Oh, I didn't actually import my. Jeez. Import. There we go. Rerun. Nope. Views is still not defined.
No pressure.
This is what happens when you really rush things.
Just relax.
You're on the clock, no problem.
This is going to be hilarious.
Most people flunk this class anyway, so just relax. We'll be here next term. Frank, you ever had a student hyperventilate in the middle of an exam?
I have hyperventilated in the middle of an exam. I used to come in, I studied real hard, and I sit there and freeze.
That's my wife. She was taking some online classes, and she just got this lazy look over her face and went, I don't know these answers.
You know, there used to be essays.
Bang,
You have all the
okay,
questions, and you're
rerun.
supposed to start writing. I had to sit there for a while.
Okay, my thing's working again.
Hey!
Okay, awesome.
Look at that.
What do we do?
When we don't pay attention to him, he's fine, right?
Yeah,
All right, so local
This is
host
pressure that causes
8,000.
the problem.
We're doing test API, and then we're doing do something. What URL did we set for this thing? It's just do something. Okay, so we're going to do a post to do something. Send us back something, please.
And it didn't say anything.
Oh, URL.
Not a good string.
Look, it says stuff.
It's CSRF verification failed. You know why that happens?
Because you're under pressure doing a demo.
Because the security's still on. I didn't send anything to satisfy it. Okay, wait. Nope, we're going to do a get.
Would you do a post before?
Yeah, we did a post. We're going to do a get. Yay, we're going to do a get. Instead. Because we're getting something now that I think about it. I did the thing!
Whoa!
How long did it take? I took 15 minutes.
Very good.
Okay,
That was one call.
we did the thing. So, yeah, that was one call, but I at least had the code to do. And obviously, like, if I wanted to use multiple verbs, I'd have to, request, do different actions for different posts. So maybe I would take something and put into a database. I'm not building a database right now. But yay, okay, fast build. Yay, it
You're
succeeded.
on a roll, why not?
On a
Hey,
roll?
You got another 15 minutes.
Yeah,
What else can you do?
Okay, let's start doing things.
Knock off the roll
How about, what if we had a, what would be a good thing to try? Okay, so, what if we had, say, a, and we had a, what if we had, what's an object we can have? A post, a comment? Can we make a comment? Sure, let's do a comment. Comment. What else? I'm going to create a data store for a comment. Comment text.
One of the things we have to do is get a bigger screen with bigger print for us old guys.
Car field.
We only
max-
have so much control
max
over what's
length.
here.
No, that's
50. Let's do max length. Oh, wait. I already got one. I don't have to do this now that I remember it. This test site actually has it's in the other one. It is in Contact Us. Because this test site has a Contact Us
Yeah,
page.
okay.
That has a Contact Us
I
message.
didn't pull it out of this.
Yeah.
City.
Oh yeah, it does. It has a Contact Us message. What if we want to do Contact Us from the API?
Oh, yes. Contact us from the API.
I don't know why you'd want to do that, but it's what I got right now. So, home dot. Yeah, I gotta check the name of that thing. No, it's not in home. It's in contact. It's actually in Contact Us. Okay, so it's in Contact Us dot models. going like, what the heck is this? Let's copy the name. Yeah, we're going to use V bindings because we're cool kids. Contact us message. So, let's do a. Oh wait, we can't do a post. God. Yeah, I'd actually have to set up a thing to get the token in order to do the post. And okay, well we'll have to scrap that a little bit. I can't do a post in here without like because it's gonna reject it without a CSRS token. Let's try something else. Let's print a message. Why not? Insert code to do things here. We'll get rid of that. Rerun. We'll do the send.
You broke something.
Yeah, I broke something. Whoa, that is interesting.
I broke a lot, didn't you?
Yeah, I broke quite a bit actually. Oh, it's because I didn't have the response data. Oh, jeez. Let's get that back. Jeez, that's what happens. I did the thing. Let's actually do a thing on this side. Let's do I'm doing something. Okay. Yep.
I get it.
You got it?
I got it.
I did the thing and oh yay, we printed the message. Awesome. So like basically if we put code in here that does something, then doing that call is going to do that thing. So if you had like a cheap, like I guess imagine if you're on a Raspberry Pi and you wanted to run a motor.
I'm running a motor.
And you want to run a motor, like you can just put stuff to run your motor here. And because this function is going, this whatever is in here is going to run when you send that API request, if that makes any sense. I think that's the extent of what I can speed build here practically.
Makes sense to me. I see
Okay.
what we're doing.
Makes sense? Makes sense. Yeah, I guess I could come back with a more extensive demo later, as well as a client, because that is a good point. Making a client that can actually consume the API. I mean, what you do is you do an HTTP request. I could come back with a demo of that as well next week probably. As what the client side would be doing. Makes sense. Okay. I think that's the extent of that. Anyone got any questions or? I'm gonna stop sharing real quick.
You
So can I have a voice interface on that?
The client would handle the voice interface, and then, but yeah.
That's insane.
What's insane? Oh, someone else's thing came up.
Upload.
So
3.2.
you did that with Django,
Yeah.
but you could do the same thing with
You can do the same thing.
PHP.
Like, as you can see, it's like I was using very basic stuff. Like I wasn't even rendering an HTML template. The only thing I was doing was like doing the generic, okay, get requests, and just
all his
read what's in it.
all the Raspberry Pi files are what were they? Were they PHP?
You're talking about what I did
When you
demo
hit the
with?
button or whatever?
Well, the PHP just serves the web page
Okay.
that gives you buttons, but the actual running of blinking the LEDs and so forth and so on, those are little mini C programs that I
And you
wrote.
call it
Okay.
you call it from the PHP.
And basically, the PHP button calls that particular program, and it runs. And the scan, which scanned all 28 of them.
Yeah.
Was the same thing. It was a little C program
Right.
I wrote that got called when you pushed that button.
Right.
Yeah, so basically, you instead of serving a page, you just read the request coming in,
Yeah.
and you'd have an endpoint that says like toggle LED A, or actually, wait, remember, toggle doesn't work very well because if it fails and you got to send it multiple times, then it's just going to go.
Yeah, toggle's not a good idea.
So yeah, you'd have like you could either have like LED A on and then LED A
Right.
off, or you can have LED, and you can kind of model it as like, okay, do a post to put in an on state and then do a delete in order to do just read the HTTP verb.
If you do a garage door opener because of physically the way it works, it's a toggle.
Yeah,
You
but
send something, and you're gonna
except
call it
like
replay.
the API would on the API side, you'd turn that into do a consistent state. Like if you have something to check the state of the garage door, for example, you'd have code in there to like, okay, if it is a post and opening, then like check if it's already open. If it's not, go ahead and do it. If it's already open, don't do anything. Just send back a success. It's already open. And things like that. So,
but if you don't have a way of monitoring whether or not it's open or closed,
then you've got an issue. Then you kind of have to make an exception.
You can actually keep something you can do is you can keep your state. You know what state it should be in.
yeah, but you don't know how the machine's responding.
But if the machines
If
fail,
the machine fails, if it misfires,
by failure, the failure we're kind of modeling is internet connection interruption and things like that. If the API side thing fails, then it's kind of
nothing's going to happen anyway.
Reset.
Then you've got an issue. Oh, that's the other thing. I mean, you want to make sure that it's easy. Like that's why documentation is good. There are frameworks that will auto-generate doc pages for calls that you make. That way, like so that the developer, which might just be you or might be someone else, can go to those pages and say like, okay, so this endpoint takes this data, or if I do this, it'll do this. That's pretty good because it makes it easy for the guy programming the other thing to know what to do in order to do a certain thing. I could probably do a more detailed build and come back with one of those next week, just so you have an idea of what it looks like when it's more involved. Because you can do things like request data, store data,
All kinds of stuff.
all kinds of stuff. Basically, it's like this is sort of the building block by which you can build bigger systems. Using things communicating entirely just over the internet, being physically in different places.
So that one demo that I did with I had the Android app I wrote and the BiddyBot that was running an HTTP server. It's pretty much what I was doing. I was using using the Arduino as the API.
You know, what I always think about the more I see these things is you need some kind of audit. Because these things can get terribly out of whack. The other thing that I'm sure happens is I'm sure that you get memory leaks sometimes. Because I run these things for days and days and days. Sometimes they go to sleep. And I don't know